Hi all! So in this video, we're going to be looking at an example of how to get the correlation between two random variables. So here we're going to start off with something we've done a few times. We're going to look at roulette. And basically we're going to have 18 red numbers, 18 black numbers, and 2 green numbers. I think we've done this a few times, so you should be kind of used to what a roulette table looks like. So NR we're going to let be the number of reds that appear in n spins. So we spin n times and we get nr reds. We'll let nb be the number of blacks, and if you want you can let ng be the number of greens, but really if you think about it, ng is equal to n minus nr minus nb, right? So you can write one as the other two. So it's not too big of a deal here. So we'll just keep them separated. So we'll just let NB be the number of blacks that appear in n spins. And the question is, what is the correlation between R and B? What's the correlation between the number of red spins and the number of black spins? So let's remember, so the correlation between NR and NB, let's remember what these formulas look like. This is covariance of NR NB divided by the standard deviation of NR times the standard deviation of NB. So why don't we first solve these standard deviations and kind of go from there? Because this should be like the easier part, right? These standard deviation stuff we've done quite a number of times. So first we need to figure out the expected value of everything, right? So the thing we know is, we know this is binomial, right? Because, so both NR and NB, NR, NB, are binomial. Since we're choosing, since we have, for example, for NR, NR out of n spins. So this is it's binomial. So in other words, what we end up having, the expected value of NR, notice how also this is always going to be equal to the expected value of NB. They're going to be identical because they have the same number of things. This is just going to be n times 18 over 38. This is the probability of one spin. So this is P for getting red. And n is the number of total spins. So we get that for both of them. And what's the standard deviation? The standard deviation in this case, well, this is equal to, we've gone over this as well. This is equal to, if you remember, in this case, it's np1 minus p. So really what we have is n times 18 over 38 times 20 over 38. And you should be able to notice that these two are the same for NB and NR. So really what we have is n times 18 times 20 over 38. Okay, cool. So we have this. And then what's the other thing? So covariance, if we remember, this is E of NR NB minus E of NR E of NB over SD of NR SD of NB. So basically, what do we have so far? We've done this, we've done this, we've done this, we've done this. All that's left at this left-hand side is the expected value of the multiplication. So we need to solve this side to figure out what we need to do. Now, this is actually quite difficult. It's not something that's really easy to do, but there's actually a second way around this, right? We don't really need to solve this. We just need to calculate the covariance. We need to figure this out on top. Well, the covariance, there's another way of looking at this, right? Remember that the covariance, var of NR plus NB, this is just the var of NR plus the var of NB plus 2 times, plus 2 times the covariance of NR and B. So we can solve the covariance by figuring out everything else here. And the nice thing is, most of these we should already know, right? This we already know, this we already know, because we just have to square the standard deviation. So these are done. The main thing we then need to solve is this. And this should be something that's much, much, much easier to solve. Why is it much easier to solve? Well, let's think about this. What is this variable? What is nr plus nb? This is telling me the number of spins, or the number of times I get red or black in n spins. Well, what is that? So in this case, the probability is 18 over 38 plus 18 over 38, red or black. So the probability in this case is 36 over 38. So the variance, what's the variance of nr plus nb? Well, this is, again, a binomial distribution, but in this case we have n times, I guess, 36 over 38 times 2 over 38. So in this case we have n times 36 times 2 over 38. So we know this variance. Wait, not square root. Why am I doing square root? No square root. That's standard deviation. So we get n times 30, that's not an n times 36 times 2 over 38 squared. So what do we have? We have that 2 times the covariance, or I guess we can divide by 2 after. The covariance of nr and b is equal to the variance of nr plus nb minus the variance of nr minus the variance of nb divided by 2. So what is this equal to? So here we have n times 36 times 2 over 38 squared minus, and the variance of nr and the variance of nb are identical, right? We can just grab this from the standard deviation. So these are equal to n times 18 times 6 times 20, times 20 over 38 squared. All of this divided by 2, and this happens twice. N times 18 times 20 over 38 squared. And if you kind of solve this, what we end up getting is that the covariance is equal to minus 18 squared times n over 38 squared. So if you kind of put everything together, that's what you get. Running out of room, but basically what we're left with is trying to figure out the covariance, right? Or the correlation, right? So what do we have? The correlation between nr and nb is equal to the covariance. So the covariance was equal to minus 18 squared times n over 38 squared. We have to then multiply by the standard deviation. So the standard deviation of nr, this is just n, let's see, so we get, this is squared, so we get n times, oh, no, it's the square root, because it's standard deviation. So it's, yeah, it's square root of n times 18 times 20 over 38. And this squared, right? Because they're going to be the same number. SDA and SDNR and SDNB. The 38s are going to cancel, right? These will cancel because we have the square, right? So the square comes here and the square comes here. And so we're left with, this is running out of room, minus 18 squared n over n times 18 times 20. The 18s cancel, so we get minus 18 n over 20n. The n's cancel, so we get minus 9/10. Bam! All of that to get minus 9/10. But now we know the correlation between getting red and getting black. It's roughly minus 0.9. So they're really negatively dependent on one another. And think about this. This makes sense. If I get red, I shouldn't be getting black. If I get black, I shouldn't be getting red. They're not kind of happening in relation with one another. So they should be very uncorrelated, very differently correlated. So we'll stop this video here. And that's it for now. So in the next video, we're going to look at the variance of a sum of many variables. And so we're nearing the end of this course. There's only 2 more sections left. So I will see you in the next video for the second to last section, and I will see you there. Bye.